I've been working on this power hammer. I'm calling it the Adams power hammer because it says Adams on the back side. And in this video I'm going to go through taking apart the ram assembly, the arms, that spring, the crosshead there, all the way down to the ram itself, which is inside that enclosure, little guard there. I don't have a lot of video about this, but we'll talk through some photos and I'll show you what I have. I thought I could take this apart without pulling the whole thing off the hammer altogether, because the ram will sit on the bottom dial, right? And with that guard in place, there's no danger of it falling off on its own. So I removed it from the pitman. The pitman is that silver shaft that the crosshead rides up and down on. I got that cleared, pulled out the cotter pins on one of the hinge pins, and pounded out that hinge pin with a brass drift. That was when I realized how much tension there is on that spring. So it actually, luckily, caught my drift in that hole where the hinge pin was, and I couldn't move the drift, and I wouldn't have wanted to pull it out anyway with that spring under tension at that point. So I ended up pulling the whole ram assembly off the hammer. You can see it down on the ground there. And then ran a piece of 3/8 all thread through the elbows, I guess, the bottom of the longer links, in order to compress that spring. It was probably quite a bit of tension for that 3/8 all thread, but it worked out alright, and that was the largest material that I could fit through there. So yeah, it seemed fine. I'm not sure if I'll do that to put it back together again or not, but we'll see. I might. So I got everything all taken apart here. It's both quite a lot dirtier than I had anticipated, and there's just dirt caked on everything. Then on top of that, the parts are in a fair bit worse condition than I thought. In particular, the hinge pins are extremely worn. I was really surprised about this. I don't know what they're made out of, but they have not held up very well. And because the pins are worn, all of the holes that they go in are also wallowed out, so those aren't round either. Here I'll bring up a pin closer to the camera. This is the worst of them. So to give a sense of scale, each of these pins is a 7/8 diameter on the major, and this one is worn down to just over 5/8 at that worn spot. So if you're not familiar with how these are supposed to look and work, they should just be cylinders. There shouldn't be any cam action there. And yeah, you can see here our 7/8 there, and then this is 10 thou, 15 thou over 5/8. Quite a bit of wear. The other pins aren't as bad, but none of them are cylinders any longer. They all have a fairly noticeable wear ring. The other thing that's a little strange is that they're all mushroomed out on one end, and I don't think they should have been that hard to get in. So given those aspects, I'm not really sure what happened with these pins. They may be like everything else on this hammer. Maybe they were salvaged from something else, and in that prior application, maybe they needed to be hammered in. But you can see there's a fair bit of flaring there. Most of them are about 900 thou on the mushroom portion, as opposed to 875 or so on the nominal. And they're all like this. Thankfully it's only one end that's flared, so I was able to get them out, treat them like taper pins. But still a little bit strange. I suspect that they're probably just a mild steel pin rather than being some tool steel like a 4140 or something like that. So the upshot is that I'll need to replace all of these pins. And because of the wear on the pins and the wallowing out of the holes, I'm going to have to find a way to uh, deal with the holes as well. I think that's probably going to be the biggest challenge I run into so far on this hammer, because there isn't a lot of material around the holes, and I'm not confident that I can weld up the interior and then bore it out to the same 7/8 diameter. So I think what I'm going to do is build up a weld around the exterior of these. Go with a same size pin, so a 7/8 pin, but then put in a like a 60 thou bushing and bore the holes out larger. So here's the crosshead. Kind of interesting to see how they attempted to do this. The design is obviously a split collar with a big clamping bolt, but there isn't enough clamping force to offset the bulk on that left hand side, and so this doesn't work at all. It doesn't hold the pitman, and so in order to get around that, they ended up putting a clamping collar above and below. Those clamping collars do work, but it makes it very difficult to adjust the crosshead on the pitman. So if you want to change the hammer to work on a different size material, it's a fair bit of work to move this thing up and down. So I'd like to find a different way to do that. And this part's also in pretty rough shape, even compared to the rest of the hammer. You can see that there's been some repair work, but also it was just not particularly well made in the first place. You can see my finger there through the clamping bolt hole. There's not a whole lot of threads. Well, there's probably plenty of threads. There's a ½ inch of threads there. But just a pretty rough part. I'd have to do a lot of weld build-up to deal with the pins I just talked about on this as well. And I think it's going to be easier to just make a new one, honestly. This part's kind of interesting. This is the tension adjustment for the spring. So it floats loose in that bore. It's actually a pretty good fit, although the parts are so dirty right now. It's hard to actually tell if it's really a good fit or if it's just it might be a little bit of a loose fit and a lot of dirt in there. It's kind of a neat design. It does just float there. It's held in by the spring tension, of course. And then that large grub screw on the back hand side is your tension adjustment. It'll move that flange in and out. The spring fits around that on the flange there. The idea being that then you can adjust your tension. It's a little hard to tell if it's actually functional though, in the sense that the spring tension seems to be more or less correct. I haven't run the hammer, but it seems to be more or less correct when that adjustment is bottomed out. So I don't know that it's actually providing any utility. But it's an interesting design. It looks like it probably would work given the right spring tension. One last little interesting bit here. So we're looking at the RAM with the top die in place right now in my vise, and I've been having trouble getting that die out. So it's held in with a long tapered key, and that key is very stubborn. So it's narrow enough that I can't get a sizable pin in the narrow side and pop it out that way. There was only an eighth of an inch space or so, and there's only a very little bit sticking out on the large side. So I tried a trick that I had seen someone else on YouTube use, which is they welded a chunk of all thread onto the thing that was stuck. So I, I welded a bit of that 3/8 all thread onto the end of the key, and then ran that square bar around it and blocked it up so that it was pulling off of the die and the ram, and then cranked it out. It worked really well. I gave it some penetrating oil as well, and I came right on out. It was a little bit stressful because there's some strange noises, creaking, whatnot, when I actually did it. I didn't get that on video, unfortunately. But yeah, worked. I'll probably do it again sometime. I think that's about all I got time for right now. But I will try to get some better video of the rest of the process here and send some more updates.